Right, MPLS layer 3 VPN. MPLS layer 3 VPN. Why do we call layer 3 VPN? The reason is the layer 3 additional encapsulation. For that layer 3, label is given. For example, I'm going to go detail into it. We have a customer edge. This customer edge is connected to a provider edge. Let's say the customer edge source of the packet is 1.1.1.1. This is the address from where you ping. And how you're pinging customer edge to that. Now the packet comes to the provider edge with the source address 1.1.1.1 and destination to that. What the provider edge does is as it receives the packet, it puts a label. It puts an IP address, source 11, destination 22. This is the layer 3 address that will be added to this PE. Now, there's going to be two MPLS layer. One label for this one, another label for this one. So let's say for reaching 2222, when the traffic comes to PE1, the label given by the service VPN, service label, the VPN given label, that is going to be added, let's say 64, which is for 2.2.2.2, the remote. This is the label learned through the tunnel. And there's going to be a label for reaching 22. That will be the label called transport label given by this P1. P1 says to reach 22, the label is 18. This gives label 21. This gives label 22, let's say. So when it goes to P1, it is going to be 18. And from P1, when it is moved to P2, it is swapped with label 21. And then from 21 to 22, and then PHP. And then it reaches this provider edge 2. In the provider edge 2, it knows the meaning of 64. 64 means it needs to go via this way, delivers to the customer. See, it is the layer 3 encapsulation for which the MPLS label is assigned. This is what stack of MPLS label layer. What does that stack means? Layers of MPLS. So you got stack of layer 3 for which stack of MPLS is given. And this is done by MPPGP IPv4 VPN address family. What it means? It means BGP can do a lot of things. One of the things that it can provide is this one, the address family that can provide you layer 3 encapsulation, for which MPLS label can be advertised over the tunnel using LDP. And using the LDP given label, the packets goes between PEs with the additional encapsulation that is needed for transport between these PEs for multiple hops like P1, P2, and P3. So we have seen here there are two layers of MPLS needed if you want to have successful layer 3 VPN. The top layer will always keep changing every hop inside the provider's network. We call it as transport label. The label that is the bottom of a stack marked 1, which is inner layer. Listen, when we learned MPLS header, we learned that there is a field called bottom of a stack. Bottom of a stack. So bottom of a stack field will be on for the 64 layer. Will be 1 for the 64 layer. Will be 0 for the transport layer. For the service layer, it will be 64. What is service layer? VPN service layer. The VPN label. Right, one more step of theory we need to learn, then we will get into the lab. Now, did you understand up to this part? If you have any question, you ask, not in the last minute when I'm finishing the class. Ask the question now. See, in MPLS, there are 20-bit reservation for label. And there is 3-bit for experimental or COS bit. And then there is 1 bit called bottom of a stack and 8-bit for TTL. Now, this is the upper layer using which the packet moves every hop. You understand that part? Okay. Now this is the label given by P2 over the VPN tunnel to PE1. So that will be popped off only after reaching PE2. Do you understand that? Okay, now the 64 and this 18. When PE1 send the traffic to P1, P1 is 18. When PE1 sent to P1, how many layers of MPLS you got? 2 layers. This is the top layer. This keeps changing every hop. This will change to 21. After 21, it will change to 22 when it goes to P3. And so on. For which, so the label field is 18, experimental field is null. Bottom of a stack. This field will be 0 for this and 1 for this. Because 18 is not bottom. Is 18 bottom? No. 64 is bottom. Mm. 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 Very correct. That is to tell the router that there is no more MPLS layer. This is the final layer that you are processing. Here in our case, we have two MPLS layers. This layer of MPLS will be popped off before sending to PE2. Yes or no? Before sending to PE2, this layer will be totally removed. Yes? If you don't know, you should know it. That's called PHP, penultimate hop popping. Now, PE2 receives the packet and it is processing it, and it is also seeing 1 as the bottom of the stack. Then PE2 understands, okay, fine, there is no more layer. If we have next layer label to give, we will give, otherwise we'll pop this off. That's it. So router 2 can make a decision whether to continue with this MPLS or break this MPLS here. Anyway, we cannot continue with this MPLS. This is via the tunnel, it is for the customer. So it breaks after knowing 64. What is 64? 64 means send the traffic to this customer. This is the label given to the customer's network. After knowing that I have to send it to C2, after seeing this number 1, it understands there is no more MPLS downstream. There is no more MPLS towards the customer. I have to pop this off and send it to C2. When we don't have MPLS layer 3 VPN, we were simply having only MPLS. See, the lab that you might have done is simple MPLS. For that, there will be only one layer, and that one layer will have bottom of a stack marked 1. So there is no top layer, bottom layer. There is no stack actually. Here there is no stack. So this will have 1. It's okay. This tell the router that there is no VPN. It's just transport. If we have 0, then okay, there is something else in MPLS on this router. This 0 and 1 doesn't matter much. Only it is important for the PE router. The middle router, the transport routers P1, P2, P3, they simply use the label and they push the traffic. That's it. Any other question? Yes, yes, yes. Mm. Hmm. Label switching. And, hmm, 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 hmm. Okay. I'll I'll put Murali's question in a more detailed way and check Murali whether I'm putting it right. Murali's question is already we have PE1 to PE2 MPLS labels and packets are getting switched based on MPLS label. So when I ping from 1.1.1.1 to 2.2.2.2, the traffic will go to PE1. There will be a label assigned and the packet will get switched hop by hop. When it is already using label, why are you having another VPN? Why are you having another layer of MPLS label? What is the advantage for this customer C1 and CE2 in having this MPLS layer 3 VPN? Is that correct, Murli? Anywhere, anything I need to add or remove? Right. Answer to your question. Tell me after that what? Hmm. Okay, okay. No. Okay. Hmm. Hmm. Fine. So question is same. What is his question? What is the use of the VPN when I'm already having MPLS between the PE1 and PE2? When I'm already having MPLS running between PE1, P1, P2, P3, PE2, when already MPLS is running inside this blue round, what is the use of another MPLS called MPLS Layer 3 VPN? That was his question. What is the advantage? What is the added advantage to the customer traffic when we have VPN? The second question is what is the purpose of that address that you have written? 11, 11, 11, 11 and 22, 22, 22. Fine. Anything else to add or remove? Hmm. Okay. Understood. Fine. So this question is P1 is using 64. In order to route the packet to CE2, it uses 64. Will PE2 use the same label? My question is, who gave PE1 this label 64? Answer is PE2 only gave the label 64 to PE1. Mr. PE1, if you are talking about 2.2.2.2, the customer network, you should use 64 when you talk to me. Who gave this? PE2 only gave this. To whom it gave? PE1 it gave. That is why PE1 uses 64 and sending the traffic to PE2 so that PE2 will know this belongs to customer ECE2. That answers your last question. Did I answer that question? That last question. Okay. Now let me start from the beginning of the story. The question is, when I'm already having MPLS inside this blue ring, why are we forming a tunnel called layer 3 VPN and having another label called service label? We already have a transport label. Every hop is providing a label and swapping a label, moving the packet to the destination. PHP happens on P3, the penultimate hop hopping. When it is already happening, means we already did this lab. That's what Murli says. అయిపోయింది ఇంకా ఎందుకు one more layer of MPLS? That is what Murli's question. Why are you adding another layer of MPLS layer, another label? ఎందుకు MPLS అయిపోయింది కదా? That is his question. And another question was, why are you having this 11, 11, 11, 11, 22, 22, 22, 22? Okay, let me start from this 11, 11, 11, 22, 22. See, these are the two address with which the tunnel is going to be negotiated using BGP. P1 knows the tunnel endpoint is 22, 22. That is the tunnel endpoint ID for P2. 11, 11, 11, 11 is that this is not customer's network. This is the network inside the provider's environment to identify the PEs. This is the address to which BGP forms peering. But still, it didn't answer Murli's question. Part of the question is answered. Why you need this address and whose address is this? This address is not of customer. This address is the customer's address 1111 2222. 11 11 11 and 22 22 is not of customer. It is of providers. Providers Edge loopback has got this address with which we form IBGP using the source address update source loopback 0. Now this is a VPN address. It is for this VPN address a label 64 is given by PE2 on behalf of customer CE2 to PE1. Now let us not get into it. I'll take you to the final answer of Murli's question in some time. But before that, I want to answer another question. The very first question of Murli is, why do you need another MPLS? I have not answered that question. I just answered what is that 11 and 22. I said 11 belongs to provider, not the customer. It is between these two address IBGP negotiates VPN. That's all I have done. If I don't have MPLS layer 3 VPN, this 1111 will be learned here, not only here. It should be learned on every router, for which I need to run BGP on every router because it's coming from outside, no? If I have VPN, I just enable BGP here, that's it. And I form a tunnel, this one, using which I advertise this 1.1.1.1 and 2.2.2.2. So none of this router in the middle, will know about the customer route. They won't know. None of them will have information. None of them will know 1.1.1.1 and 2, but still they route the packet. Why and how? Because P1 and P2 and P3, they only see this top layer, not the inner layer of the packet. That is why I need VPN. If I don't have VPN, then all the customer's route will be learned on every router inside the provider. If every router starts learning customer's route, the provider may not have enough resource to handle that. Then every single router of provider need to be a very big cloud. Very big cloud. Not possible. So only the PE1 and PE2 routers are big giant routers like ASR. The middle three router which I circled with orange, they can be a normal IP router. Simple router which knows MPLS, Aste, Ante. That's all. Only that much. Other than the Podu. Atramadi. P1, P2, P3. If it has just IP support, IP routing with MPLS, that is enough. So if you have VPN, you no need to run BGP on all the middle routers. Plus, you no need to handle the routes of the customer. So you no need to provide labels for all those customer routes. It is the label to identify 22 is what the 64 is. The 64 is not identified with 2.2.2.2. The 64 is to go from here to this jump to PE2. 64 identifies 22. The VPN endpoint. So using which the packet goes directly to PE2 from PE1. But to go to PE2, there is local switching needed, no? So label 18 is for the 22 local. Label 64 is in order to reach the customer 2.2.2.2 on that router 22, label 64. So you can say 64 as a service label. What service you provide? The tunnel service. To pass the tunnel from this end to that end, you need the 64. But to have the tunnel, meaning to jump between the routers till the tunnel endpoint, you need local switching, for which you need this upper layer. So without the base MPLS, switching from this P to that P is not possible without that transport MPLS. Transport. And without the service VPN label, going through the tunnel is not possible. So to establish tunnel, you need transport VPN between the P. To use the tunnel, we need service MPLS through the tunnel. And LDP provides label in both transport as well as in service. Over the tunnel as well as over the physical hops, it's the LDP the one who provides the label using which the packets are forwarded. So answer to the question is the MPLS that you first enabled, they don't know the labels to reach 22222. They know only up to 22, 22, 22, 22. Now the second MPLS that we have, we call this VPN or service. VPN or service. It uses the reachability between 11.11.11 and 22.22. Provides a label for the customer network 2.2.2.2 and 1.1.1.1 through the tunnel. So when a customer traffic from C1 comes to PE1, P1 says, hey, I got a label for 2.2.2.2, which is 64. But to go to 64, you need to go through the tunnel, for which first you need to go to P1, take this label, 18. 18 means what? 22, 22, 22, 22. So P1 says, I know, take 21 and puts label 21, swapping with 18, it puts 21, sends to P2. P2, when it receives 21 label, it knows that the traffic belongs to 22, 22, 22, 22. P3 receives 22 label and it swaps the it pops the label. It pops the label and send it without any transfer label. And PE2 receives label 64. PE2 only gave 64 for the network 2.2.2.2 of customer. So it knows this packet belongs to 222. It delivers the packet to CE2. Yeah. If any question, please ask. Of course. C1's routes are learned in ISP's routing table, but not on all routing table routers, only on the PE routers. And P1 and P2 forms a tunnel for the customer. Using that route distinguisher and route target, which we are going to see in a few minutes once again. For all this, we have to pay. It's called WAN service, MPLS WAN service. MPLS tunnel. It's a costly one to get. Even today it is costly. Yeah. Hmm. There is no BGP in between PE1 and PE2. BGP is only on PE1 and PE2. There is no BGP on in between routers. There is no BGP on P1, P2, P3. No BGP. As a result, there is no chance of P1, P2, P3 to learn customer's route. But what they already know is through OSPF, they know how to reach the tunnel endpoint 11, 11, 11, 11, 22, 22, 22, 22. Whenever customer speaks, the packet is going to be encapsulated with the destination address through to 22, 22, 22, 22. So the middle router, if they know simply the 22, 22, 22, that is enough. All right. Okay. Please. Hmm. Hmm. Correct. See, let me draw first your question because it has got two answers. CE1, CE2, P1, P2. So our topology is only this much. There is no any middle router. Correct? All right. So in this scenario, Giri's question is, he didn't ask that question, but that is what he is going to ask next. Do we really need 2 layers of MPLS? So that's going to be his question. But what he has asked so far is confirmation. 64 is advertised for the transport. Now, will there be a stack of label? That can be his question. If I elaborate his question, that can be his question. Will there be 2 layers of MPLS? Secondly, is it really needed? If I didn't put your question correctly, correct me, Krish. There's nothing more added, need to be added. Okay. He was using the number 64, 18, all the stuff. So instead of asking question, he is just checking whether what he understood is correct. My answer is there won't be a stack here. There will not be any stack. Why? Because for this router, this is the PHP router. Likewise, for this router, this is the PHP router. Penultimate hop popping. So there won't be a transport label, only a tunnel label. Only a tunnel label. For this customer 2.2.2.2, a label number, let's say 64, is given over the tunnel, and it is reflecting here. So when this guy pings from 1.1.1.1 to 2.2.2.2, when the packet with registration 222 comes, it is placed into 64, and it is transported to the very next hop. Because its very next hop, there is no label. It's pop label. So packet goes there with 64, with bottom of a stack 1 marked, and PE2 process 64 means it is for customer C2. Now, is this needed when we have only 2 PE routers? Just 2 routers. Is there a need for a VPN? Not at all. The layer 3 VPN is not needed. Simple MPLS is enough. That also, to avoid layer 3 scanning. See, you still need MPLS. But BGP, MPBGP means VPN v4 is not really needed. Sorry, even this is also not, MPLS is also not needed here. Nothing is needed here. MPLS is also, anyway, you are going to scan entire layer 3 because there is no label for PHP, only one hop. So there is no need for MPLS. And also there is no need for a tunnel. Why? Tunnel is needed only if you have many routers in the middle where you don't want to run BGP. Tunnel is needed only when I do not want to have the middle routers between PE1 and PE2 to run BGP. When I do not want the middle router to learn the customer's route, I want the tunnel. I don't want any of the middle router to learn the customer's route. So I want the tunnel. I want the tunnel. Now I don't want tunnel. So this scenario, there is no need for MPLS layer 3 VPN. What this topology needs. That will take us to next topic. And we already started the topic in the previous class called VRF. You see this customer C1 and C2 is same customer. This is local office. This is branch office. There is another customer, red CE2, red CE1. So there are 2 customers in our topology. One is the brown customer, another one is the red customer. Now this brown and red. They need their own, they need a separate control plane. So I'll create a red routing table using VRF red and a brown routing table using VRF brown. And there is already another routing table called default routing table for the internal networks. So for the inside networks, you have a routing table. To maintain the brown customer's routing table, you got brown routing table. And to maintain the red customer's route, you got red routing table. So we have VRFs now. All that you need to do is extend the VRF brown to brown, red to red, brown to brown, using a concept called VRF light. This is the only scenario where this VRF light will come into picture. Light, very light, not heavy. See, there is no need of BGP, MPLS, MPBGP VPN. There is no need for MPBGP VPN. There is no need for layer 3 VPN. You need simply VRF light to connect this routing table and that routing table back to back. That is enough. So about VRF light, we will see later, meaning after layer 3 MPLS VPN. Let us not get into VRF light. I'm just answering our question, Girish question. What is well suited in this topology? VRF light. Atramadi. Question. Please ask question if you have any. Did I answer your question, Girish? Welcome. Right. So a quick reminder, VRF is a virtual routing forwarding. It is to create multiple control planes, multiple routing table inside one physical router. To differentiate the red customer and the brown customer, there is a separate number given for each VRF. See, I'm using the word red, brown, but router will not know that red and brown. You need to put some number and tell this is different, that is different. We call that as route distinguisher, which is 64-bit value. So to the router you have given the difference. But when the packet, when the updates go through the tunnel, how the tunnel can differentiate whether this is for brown or red, so that the tunnel can deliver it to the correct customer. When brown sends, it has to deliver to brown customer's interface. When the red sends, the tunnel should deliver to the red customer for connected interface. So the tunnel also should know whether this packets, updates belong to brown or red. How the tunnel knows? It knows through another 64-bit value called route target. Only with the target I know to whom I have to deliver. So that's the meaning of target. Destination, to whom I have to deliver this. To whom it is targeted. To whom it is targeted. யாருக்காக இது அனுப்பப்பட்டிருக்கு. Is it for red or brown? For whom it is sent. Is it for red or brown? That is known through the 64-bit value called route target. What, Sam? What is route target? Route target is a 64-bit value that tells the tunnel to whom this packet or update belong to. Did you understand that? Now, I have never heard anyone speaking in Philippine language. Can you put this statement in Philippine language? Let me hear from you. Route target is a 64-bit value that is attached to the packet so that as they go through the tunnel will know to which destination this packet need to be delivered. How you will say in your language? Let me hear, if you don't mind. I'm sorry, what did you say? I thought you were speaking in your language, but you were speaking in English. I'm sorry, Sam, I didn't hear you. Okay, all right. So, how do you say I'm better with English in your language? Wow, something very nice to hear. Okay, if God willing, let me learn your language. All right, then the knowledge that I have shared under MPLS, you should know very well to understand next class. So watch the videos of previous class as well as today's class. And I'll meet you in the next class. Take care. Bye bye, all of you.